Hi everyone, Yvonne here with another episode of DevWidgets. Today we will continue our event microservice by building out our REST APIs. All right, so if you've been following along with this series, you know that in our first video, we designed what our serverless infrastructure would look like on AWS Cloud. In our second video, we actually started building out a skeleton application and we implemented our infrastructure, or at least part of it anyways, with CloudFormation. Today, we're going to actually start writing code that will build out and serve our REST APIs using Spring Boot framework. All right, so here we have the application that we have been working towards, right? For those of you who are new, basically there is an application, whether it's on a mobile app or whether it's on the browser, that is going to make REST APIs calls to our application to be able to get a list of events that are coming up. So it has a description and a date, and this is what's going to happen, for example, right? And we already went in and we did a skeleton application in AWS, like I mentioned, and we have just a bare bones skeleton Lambda application that is hosted with CloudFormation and using SAM CLI. So we're going to go into this Lambda here and we're going to actually build out the code. I've talked about this before. Let's go into it a little deeper. We're using Hexagonal Architecture. And so basically what that means is there are inputs and outputs of our application, but each layer of this application is fairly isolated, right? So there's a domain layer. The only person that talks to that domain layer is the application layer, right? And the application layer, it makes requests out to either third-party applications or other things, or it gets requests in from controllers. And so this outer layer is that in and out communication of our application. So what we're going to build today is the controller piece, and that is going to handle our REST APIs and then route it to the application layer. Now, for today's purposes, we're just going to stub the event that gets returned, or the events that gets returned from the application layer. But then in a later episode, we're going to actually build out the DynamoDB side of things and our domain layer communicating with DynamoDB. So let's go over the steps that we're going to do today. All right, to start with, we are going to use the Spring Boot application. That framework, sorry, not application, the Spring Boot framework. And that's going to do a lot of the heavy lifting for us around handling REST APIs. So the first step is configuring Spring Boot. So Spring Boot. And as we looked at our hexagonal architecture, I'll leave this close by so that we can reference it. There's a couple things that we're going to build out. First, we're going to go ahead and do the application layer. And once we do the application layer, we'll do the controller that's going to communicate to that application layer. Controller. We'll then update our Lambda handler. So that it now goes to the controller directly. Right now, if you remember, and if you've been following along, our Lambda handler returns stub data. So that stub data, we're going to move it into the application layer. Let's see what else. Okay, so once we have that in place, we are going to actually configure API Gateway. If you were following along in the last video, I said we were going to do API Gateway at the beginning of it, and I forgot. But either way, we weren't going to really use it at that point. In this point, we're actually going to go and make some of these REST API calls and test out our application. And so we're going to create a greedy proxy. I'll go into more details what that is, but basically all REST APIs will go into our Lambda. And then the last thing is we're going to go and see this actually working in Postman. So if you're ready, let's get into this and keep on coding. All right, so our starting point is our last application that we worked on in the previous video. One thing to make note is that I upgraded JUnit to Jupyter because the Spring dependency for test assets for testing already comes with Jupyter. So the previous test that we had, the Lambda handler test, that's already been updated. And you'll get that in the Git project. All right, so here are the Spring dependencies. So we have the web dependency. I mentioned that the test dependency pulls in Jupyter, and that is pretty much it. Looking at some of the other versions, I think everything can stay as is. Actually, wait. If you notice, the Spring does not include the version number, so let me copy that. All right. One second, I'm getting it off documentation. All right, here we go. So we have our version number. This may or may not be the latest. I'm not sure. When I originally created this project, it was a couple months back. We have to also add, because we're using JUnit, Jupyter, sorry, we have to add this so that Gradle can use the JUnit platform to be able to run all the tests. Then there's one other thing that I need to add. So it's jar enabled true. So I noticed, I don't really know the science of it other than it was a very hard process to figure out. But Spring Boot creates I guess maybe it has its own jar and it creates its own bootable application. And for whatever reason, with SAM CLI, without me adding this jar enabled true, it wouldn't create the right deployable Lambda or the deployable fat jar for Lambda. So add that in there. It'll save you a headache. I'm sure maybe it's somewhere in some documentation that I overlooked, but it did take me a while to kind of figure out that that was missing, and that's why my Lambda was not working correctly. You'll see like an error that has like can't find your Lambda handler. Okay, Jackson. I do need a newer version. I think it's actually, let me check. I think it's 2.11 something. All right. Okay, so 2.11.2, if I can write my numbers correctly. And that should be pretty much it. I may not even need this JSR 310, I just haven't figured out if it's necessary. Okay, so let's get started. We're going to do this in a test-driven development fashion. If you remember where we left off, we had our Lambda handler test and then our Lambda that would just stub data, right? And so we want to go to the next step and we want to create our application layer. And let's see, do we need any more dependencies? No, I think we're good. So let's get started. Java class. So this is going to be in IO DevWidgets events dot application. And then I know this is going to be a service class, so let's just do application dot service. And then the class will be event service impl. And this is our test class. So enter. Yes, add it. All right, so let's instantiate our event service impl class, our subject under test. Equals new event service impl. So you're seeing these compilation errors while I'm going. And in test-driven development, you technically are supposed to have a broken test. Then you fix it. Then you make another change. It's going to be broken. It will fail. And then you fix that issue and so on. So here we're going to create our first test. Get event. And all it really is going to do is, sorry, not thinking straight. My event is going to take a parameter of ID. For now, let's just pass null. And again, so we have compilation errors, right? Because we haven't created this class. So we're going to go ahead and create that class. So let's go back to our main Java files and create. No, I just need, well, let's start here. Okay, it's going to be under API REST. No, sorry. It's going to be application.service. Kind of jumping ahead of myself. And so in here, we're going to have an impl package as well. So it's going to be impl dot. And I'm kind of working backwards here, right? So I'm going to create my class and I'm going to put it behind an interface and we'll keep going. Wait, I can't spell. Service. Oh no. Rename. Okay. So let's import, and we still have a compilation error. So what are we missing? We're missing a get event. So let's go implement that method. It's gonna return an event DTO. If you remember, we created this class in our previous video. Return null. So if we go back to our tests, everything is fine and technically it passes, right? So we're gonna make another change to our test, and then again, it's going to fail, and then we're going to fix that. So let's create our event variable, and then let's assert that this variable is not null. But of course, you know, based on what we've done before, it is, right? It's going to fail. So let's run that just for sanity's sake, and you can see expected not null, and it was in fact null. So let's go back and implement that. So we are stubbing here at our application layer. So event DTO, beautiful, run my test, and then it passes. And so let's take it to another level. We need to now assert the details, right? Because, okay, fine, the event is not null, but what is it? What does it have? So we're going to do assert equals, and we are going to get description. All right, so I'm going to copy this from our old Lambda test. Technically, this test, we need to delete it. I'll delete it shortly, but there's a couple things here and there. Since all the assertions around stub data is really going to move to our service impl, I'm just going to keep it around so that I can keep checking it. Okay, so let's rename this. Event details is going to assert that this is going to fail. Of course, let's change that. So if you see, expected event is now, but it actually got null, which all totally makes sense. And let's copy that stubbing. So copy this, bring it in here, and then return event DTO variable. And it failed. Why did it fail? Okay, the date. And this is fine. We actually, I want to change it. So originally when we did this in the previous video, it just returned a date without the time zone. That is not necessarily correct, right? Because we are, the time matters, right? Whether this is East Coast or West Coast. So let me update that. And there we go. All right, so we have passed. So I'm going to give you as homework. You know that there's another API that we're supposed to have for getting events. This is the API here. I want you to try to do that with a test-driven development fashion and create that method. Of course, if you get stuck, you can definitely go and look at the Git project on what it's supposed to be. But now that we have fully fleshed out unit tests, we can go ahead and refactor this class and keep running our tests again. So IntelliJ is very helpful here. I'm going to refactor some of my duplicate code and clean up some warnings here. And you can go and keep running your tests. So let's run this again. And everything should pass, right? Because we haven't changed business logic, but we want to have some sort of confirmation that it worked. All right. So there we go. Go ahead and give that a shot. I believe you can do it. So we're going to do one more refactor. Remember I said that we should really have an interface here, right? It kind of helps us, have clean APIs of what is public, what can consumers use. So let's go and create that interface. So new, wait, do I need this? I do. So application, actually no, this is going to fail. I need to create the class. Java application, the service, and now here's where we want our interface. So event service. Okay, let's add that. Now let's go to our class and we see everything is fine, right? But our event service it doesn't implement this interface yet. And we need that to happen. So let's go to that class. You can see the error here. All right, so let's do implements event service. And you'll see these errors here. They're not being used now. Why are they not being used? So if we look at our test, actually, let's just do it this way. So if we look at our test, you can see these compilation errors. You see line 24 here. It doesn't have access to that get event anymore or get events anymore. So let's go ahead and add those APIs to event service. So here we can go and simply put, how did I get there? Override, and then pull method event to the interface. And we're going to do the same thing for our get events. And now we should be able to go back to our test. And now you see we have no more compilation errors. Let's run this. And everything is fine. Okay, so that's our interface. Oh no, wait, are we done? No, we have one more thing. We need to add the annotation. Okay, so Spring Boot, right? We need to tell Spring Boot this is a component that you need to, why doesn't it show up? Oh, let's load our Gradle dependencies that we added earlier. Now it shows up. So import SpringWorks stereotype service, which all of that implements. It's one annotation that basically, if you go into it, it adds the component annotation so that Spring will know to scan it. To load it as a bean, I shouldn't say scan it. Okay, so let's start with our REST API now. So we talked about hexagonal architecture. We have inputs into our API inputs. We have the input, the Lambda one, and now we're going to create the REST one. So let's create a new Java class. This is going to be event controller. But I can't spell. There we go. Let's add that. And again, we need to add a couple annotations here, but I am going backwards. 1 second. Let's do the test first. This is going to be true test-driven development. So Java class API.rest. And then event controller test. And add. So I could have done a shortcut within that new event controller class that I created and done Command or Shift Command T, and then it would have given me a pop-up to generate this with kind of the boilerplate methods that we needed. But I kind of want to stay true to doing event-driven, so let's do this way first. So let's create our controller field so that we can reuse it in all the tests. It cleans it out, creates a brand new one. Void get event controller dot get event. And so we have a compilation failure, right? So let's go fix that. Null. So we go back to our event controller and let's add that new method. Public event DTO get event string ID return null. So we can go back to our test. No, here. And it works. So let's add another assertion. We want to assert that it's not null. So we're gonna save this to, actually, you know what? Let's add our Spring Boot annotation. Sorry, I'm a little all over the place here. Okay, we need to add at sign and REST controller, and then we need to add our mapping request mapping. And so all APIs within this controller are all going to start with v1, and this kind of helps us if we need to do a major refactor, we need to change the contract of what this API is going to return, because let's say we have consumers, we can't just blindly change it, right? Because all those consumers would break. If it's a mobile app, you know, your end users might not necessarily update, and that app needs to still work for them. So v1 helps us do that. All right, so the first API that we're creating is event get ID, and you notice the squiggly line here. It's telling us that we're not telling Spring where that dynamic variable is. So to do that, we do at path variable, and then we tell it what the name is, equals ID, and then that squiggly line went away. Okay. And one other thing, it really shouldn't return event DTO. That was a mistake. It should be really a response entity. And that would give us, you know, like our status codes and such to the front end. So we're going to run this, everything passes. Now we're going to say that our event assert not null, that the response we got is not null. And it is null, so obviously. Event DTO. Okay, so right now, yes, it's returning event DTO, but we're still passing null. So we're going to do a check for assert, not null. We're going to check that the body of our HTTP response is not null. And this is going to be null. So run it so that you can see it in action. And it's expected not null. So let's go fix that now. So the next step of our test is we could stub it, right? But we're kind of past stubbing. We've decided that our service layer is what's actually going to return that stubbing data. So we need to create a constructor. No, this is, hold on. We want to call our event service. So we need to create a constructor so that Spring Boot will take care of our dependency injection. So our public event controller, and it will inject an instantiated event service impl. Service, this dot service equals service. Let's create the field. And now let's just use it. So service dot get event. And let's pass ID. So we see we have an error here. So now we're going to use Makito. Makito helps us. We're not testing the service layer. We have already tested that, right? So we're just going to mock a response for that service layer. So let's see if I remember this. Extend with Makito. There we go. Extension.class. And then I do at mock, and we're going to add our service here. So private event service, and then pass it in. And now we need to say so if you see, it doesn't return anything, right? So I wanted to show you that we actually need to mock that response. It's still returning null. So what we do with Makito is we say when service.getEvents, and I know that the parameter is null because that's what we passed to it. We're going to say then return, and then new event DTO. And I'm going to cheat. Let's just copy the stubbed method. Create stub DTO. Okay, so whenever our code calls service get event, return that stubbed object. And that's pretty much it. So now let's go a step further. And let's actually verify our content. And technically we don't have to verify the content because the reality is we are just proving that what we stubbed, it gets returned, and that seems a little waste. So instead, Makito also has an option where you can verify that it actually called this API. So verify service, and it called it one time dot get event. And then run it. Oops, details. So this will pass. I'm also challenging you to go ahead and let's create our list method. I believe in you. You can do this with event-driven architecture. Again, if you get stuck, it's going to be in the Git project, so you can take a look. These are mine. You could cheat theoretically and pause here, but definitely challenge yourself. I think you can do it. So we have two APIs. We have events get ID and we have events, and it returns a list. We have our annotations here that this is a component of type REST controller, and we also have our service layer. So let's go ahead and create the glue that brings this all together, which is a Spring Boot, our Spring Boot application config. Spring Boot application config. All right. So let's annotate it. Let's tell Spring that this is a application. And then we need a main method. Oh wait, component scan. So remember I told you Spring Boot will do dependency injection for us. So let's go ahead and tell them what packages should it search for components. So I'm going to copy reference because I'm notorious for misspelling things. I'm sure you've seen many misspellings throughout this. I apologize in advance. So now we need to create our main method. So this is a typical main method you see with args. Nothing interesting here. And now is where the interesting part comes. So we do Spring application dot run. Then we give it our config file, add class, and then pass any arguments that come in. And that's really it. This is like where the magic happens. So we have Spring Boot application. It's going to search all our packages for components to do dependency injection. And now we need to simply update our handler to package the request into something that Spring Boot understands. So let's remove all of this. Delete. And then we need to add our dependency. So Lambda has a dependency, Amazon. AWS Serverless has their dependency where it takes a request and converts it into Spring Boot request. So we are going to change a couple things around here, and then we need to create. So there's going to actually, let me copy this from the documentation because I'm not going to remember. Here we go. Okay, so when our Lambda instantiates a new Lambda instance, it is going to call this static block and initiate our Spring Boot application. And then let's refactor this because it used stream handler instead of the API gateway input. So input stream, then output stream, output. Let's import this. Nope. Handler dot proxy stream input, comma, output, comma, context. Oh, I gotta change the return. So this is void. So Spring Boot will automatically add our response to that output stream. And we need to, what do we need? Unhandled exception. So add it to the response. Let's clean up our imports. That would be my son in the background. All right, so our handler gets instantiated. The stack block is called. It then goes to our Spring Boot application. It then runs this by then searching our packages, which will then give it the REST controller because we have that at REST controller annotation. And then we can drop here and it's going to do the dependency injection of our service bean, our event service bean. And then now let's just bring it all together by adding our API gateway. So we need to add, I'm going to copy paste this from the Hello World SAM project, because actually no, let me I forgot, we're going to do the greedy proxy. So let me look at my notes because I don't always remember everything off the top of my head, but let's call this proxy API greedy. And the type is API of our event. The properties is path colon equals space equals proxy, so pretty much anything. And then the method, any method, right? So get, delete, put, post, options, etc. We can handle our own cores. Spring has annotations for that. And then let's get an output here of what our actual API is so that we can test it out. So event API gateway. Description. So implicit, I guess it's not technically implicit, but it creates a resource that we did not create for API gateway. And then I'm going to paste this from the Hello World one because that one is pretty straightforward. So this is an implicit resource that gets created, serverless REST API, and there's the region and then /prod. There's a stage one too, /stage, I think. But we're just going to go for prod. And we can clean this all up with further CloudFormation configuration to do our own custom domain. We can do that in a later episode. But let's deploy this. There's not really too much interesting here. Just gonna build it, then package it, and then deploy it. So right now, it is in the deployment step. Patiently, all right. So we just have to wait, update in progress. You can take a look at some of the resources that get created. Okay, so here's our new URL. Let's go to Postman. Take out all this extra stuff that it got copied. And then v1 event. And this is technically wrong, right? Because we have to do event then /id. I just want to show you that it's going to return 401. So let's do /123, enter. And this is our stub data. So let's do the list one. And there you go. You see our JSON object is a list of events. And again, let's just do gibberish here. And you'll see Spring Boot went ahead and for us returned 400. All right, so let's look at what we built. Let's look at our list. I love checking things off of lists. So we did our Spring Boot configuration. Wrong side. I don't think you can even see that. Okay, we did our Spring Boot application. We created the application layer. This had stub data. We created the controller, and the controller hooked in and called the application layer. We created our Lambda handler. That our Lambda handler started our Spring Boot application, and then it converted the requests that it got from API Gateway into something that Spring Boot could understand, and then call in and follow the chain down to the application layer to get the stub data. We configured API gateway. We configured a greedy proxy. So you saw that I was able to call /events. I was able to call /event123, and I was also able to send it gibberish. And you saw the failure, the 404 failure. And then we went to Postman, and then we called it, and so that pulled it all together. Okay, for our next video, we are going to actually hook in our Lambda with DynamoDB. We are actually going to persist some of our events into DynamoDB and then create that plumbing that we need to take those objects in DynamoDB and return it into our application and all the way back up to the front end. Thank you so much for spending this time with me and for going through this. Thank you so much for spending this time with me. And I am so excited if you have been following along that you have gotten this far, that you have actually gotten to the end of this video, which is starting to get a little meatier and longer. I will work on the length and make them a little shorter. But yeah, you've done a great job. You have, used CloudFormation. You have used Spring Boot. You have worked with a Lambda handler. You have worked with putting everything together. That is not an easy feat. We got through a couple hiccups together and we solved those problems. Some of it was guessing. Some of it was a little more scientific than that. But you did a great job. I'm really proud of you. Most importantly, happy coding. If you like this video and you want to get a notification for the next one, please definitely like and subscribe. And I will see you next time. Bye.